Good morning, children. Today we are going to discuss about the word permutations. Okay, what permutation is, why we use it, and how it can be combinations can be done. Okay, that how we can arrange it. A permutations is a arrangement in a definite order of a number of objects taken some or all at a time. For example, we have a number with 6 letters. Okay, if I need to arrange this in a group of three numbers, okay, 6 numbers we have, in order to we can arrange this in the group of three each. That means we can arrange this in the form of 6 objects 3 at a time. In that case, 6 objects 3 at a time. In that case, it will be something like 6 objects taken 3 at a time, 6p3. We generally write in this form of 6p3. That's how the arrangement is done. 6 different numbers, 3 each. We can arrange it in the form of 6p3. Okay, that's how the permutations is required. That's in the form of arranging particular objects. Next, theorem 1. Number of permutations of n different objects taken r at a time, where r lies between 0 and n. It can be equal to n as well. And the object does not repeat. That's what the thing is. Object should not repeat. In that case is NPR. The representation is NPR. N on the top and P on the suffix and prefix. We will write it. Okay. What does NPR generally defines? NPR is nothing but factorial n and n minus 1 factorial. That's what the value is. Clear? N different objects taken r at a time. R group we have taken, that is n factorial and minus r factorial. Now here in this case 6p3 I have taken. 6p3, here n value is 6 factorial, 6 minus 3 factorial, 6 factorial, 6 minus 3 is 3 factorial. 6 I can write 6, 5, 4, 3 I will weight it here because in the denominator 3 factorial is there. I am cancelling it. I think 6 5 is 30, that's 120. Clear? That's what the theorem 1 says in case of permutations. Now what does theorem 2 says? We'll talk about theorem 2. Permutations theorem 2. Number of permutations of n different objects taken r at a time where repetition is allowed. In the previous case NPR, here repetition is not allowed. Okay, but repetition is allowed means the value will be n to the power r. That's what the solution will. Let's say an example. 3-letter words can be formed from the word number. NUMBER. 3-letter word, let's say number, like this. How many words, 3-letter words, we can find it out. We'll see. How many letters are there? Total 6 letters are there. Now if repetition is not allowed, 6 letters taken 3 at a time, I can write it as 6p3. Okay, 6p3 is, I can take it as 6 factorial, 6 minus 3 factorial. That is NPR formula I am putting it. This is 6 factorial by 3 factorial. 6, 5, 4. Just now we have done it. Equal to 120. We got it. Now the word repetition is allowed is there for here, but here in this case repetition not allowed. Okay, in theorem 1 we have seen when repetition is not allowed we will use NPR, that is 6p3. When repetition is allowed we will write it n to the power r. N is 6, it is 6 to the power 3. I think 6 into 6 into 6, this should be something like 216. Repetition in the sense ki I can write it NNR, ER, like this we can use 3-letter words. Clear? But if repetition is not there, NPR, repetition is there, n to the power r. That's what the theorem 2 of permutations and permutations says. Clear? Please go through it. Any doubt, go through the example questions. Any doubt, please let me know. Thank you. Have a nice day.